Hi, this is Team 4. The topic we choose for our assignment is Smart Streetlight System. I'm Eric Fu, the leader of this team. For our problem statement, static streetlights waste energy and don't adapt to visibility. Weather and brightness are not considered in traditional systems. No visual cues for public weather awareness. And need for a low-cost intelligent solution. For our project objective, detect brightness using an LDR, simulate sunny, rainy, and cloudy weather via RGB LED, adjust LED brightness automatically, and switch between weather modes manually. For our research and innovation, we are inspired by solutions from Circuit Digest and Smart City concepts, and we improve them by adding color-based weather feedback, simulating light and environmental conditions in real time. We also have some references to UN SDGs and Sarawak Digital Blueprint.
uh, Prototype. In this prototype, we have EP32 LDR, which is light dependent with sun and push button, and RGB light, which provide brightness adjustment or color indication. Okay, for this, for the information for the EP34, this is a brain of the system, a handling sensor input and controlling output in the real time to provide Wi-Fi capability for future IoT expansion and remote monitoring. Next is LDR. It is light dependent resistor. It is measure the intensity of the edge light. This sensor allows system to determine whether it's day or night and adjust the street light brightness accordingly. And now it's on to RGB light. It is very simple. It just change the light or brightness when it's on or off. And that's all from me. Thank you.
I'm Jia Wei, and today I'm going to talk about how our automatic streetlight controller circuit works and the functions of it. So there will be 3 functions within this coding over here, and it's shown over here, and the circuit being set up. So the first function will be light detection with the LDR, which is the light dependent resistor, and the LDR will sense how bright the surroundings are, and it gives a value between 0 and 1023, which is very dark and very bright. And this value is read using the ESP32's analog pin, and the system uses this value to adjust the brightness. If it is bright, for example, the daytime, the LED dims or turns off. If it is dark, for example, night times, the LED brightens. The second function will be weather detection with push button. The push button simulates a change in weather. Every time you press it, the weather state cycles between sunny, which means the light turns yellow, rainy, the light turns warm orange, or cloudy, where the light turns bluish. Since this is just a simulation in a real-world setup, the weather could be detected using sensors or IPS. So you can see from the LDR value here, that is being shown here, that the LED is bluish and the LDR value is between all these values, which means the weather is quite cloudy. And the number 3 will be the RGB LED lighting. The RGB LED represents the street light. It uses 3 PWM outputs, which is red, green, and blue, to mix colors. Based on the weather condition, it changes colors. Also based on the LDR value, it changes brightness by adjusting PWM duty cycles. So that's all from me. Thank you.
Hello, it's Hii Neng Xiang here. Now I will talk about the conclusion and future work. So for our conclusion, this project demonstrates basic IoT and sensor or actuator interactions. And for our future upgrades, we are considering adding Wi-Fi and weather API, OLED display for conditions, and mobile app integrations for smoother and more comfortable user interface. That's all. Thank you for watching.